Second white coat. Subscribe and like. Let's learn medicine together.
All right, today we're going to solve a fascinating medical mystery. It all starts with something pretty common, a headache. But you'll see the final clue shows up in a really unexpected place, how a patient moves their hands. So let's start putting the pieces of this puzzle together. And this right here is the central question of our case. I mean, how can a symptom in your head, a throbbing headache, point directly to a problem with how you coordinate your hands? They seem totally disconnected, right? Well, the answer is hidden in the incredible and kind of tricky wiring of the brain. Let's start with clue number 1, our patient.
Okay, first up, let's meet our patient and get the basic facts straight from the case file.
So, our patient is a 54-year-old man, and he's been dealing with headaches that have just been getting worse and worse over 2 months. Now, the pain is throbbing, he's got nausea, but here's the critical clue. It gets way worse when he coughs or strains. He even says this just feels different from the migraines he's had before. Now, for a doctor, that's a huge red flag that this is not just another migraine.
So, what are these clues telling us? Well, they're all pointing to one big thing: increased pressure inside the skull. You know, think of your skull like a sealed box. If something inside starts taking up extra space, the pressure builds. And when our patient coughs, that pressure spikes, making the headache so much worse. This isn't a migraine. This is what we call a mass effect.
So the next logical step is pretty obvious, right? We've got to get a picture of what's going on in there. And the MRI, well, it gives us our first major break in the case.
And boom, there it is, a cystic mass in the left cerebellar hemisphere. This one finding is a game changer. It takes us from a very general problem, too much pressure in the head, to a super specific location. We now know exactly where to focus our investigation.
Okay, so now that we know the where, we need to understand the what. I mean, what does the cerebellum actually do? Let's take a quick tour of the brain's master coordination center.
This here is like a functional map of the cerebellum. And what's so cool is how specialized it is. Think of it like a control panel with different sections for different jobs. You've got that central part, the vermis, and then these big hemispheres on the sides. Each one is in charge of something very, very specific. And this table makes it even clearer. See, the vermis handles our core posture, our walking. That little flocculonodular lobe, it's all about balance and eye movements. But our patient's mass is in the lateral hemisphere. And just look at its function, motor planning for your limbs. So the key takeaway here is that the problem isn't going to be with his walking or his balance. It's going to be with the coordination of his arms and legs. Okay, here's where things get really cool and honestly, a little weird. To figure out the exact symptom, we have to understand this fundamental rule of how the cerebellum is wired. It's a neat little neurological twist.
So most of us learn this basic rule in biology class, right? The left side of the brain controls the right side of the body and vice versa. But if you apply that rule here, you'll walk straight into a classic neurology trap. The cerebellum, it turns out, plays by its own set of rules.
And this slide shows you the trick. It's called a double cross. First, signals leave the cerebellum and, yep, they cross to the opposite side. But then, and this is the key, the main motor pathway that actually controls the muscles crosses back again. And what happens when you cross twice? Well, you end up right back where you started. And that is the simple, powerful takeaway. A lesion in the left cerebellum causes problems on the left side of the body. Same side, every time.
All right, let's put all the pieces on the table. We have a mass in the left cerebellar hemisphere. We know that specific region controls limb coordination. And we know, because of that double cross rule, that the symptoms are going to be on the same side. It's time to solve this case.
So I'm going to ask you directly, with all this information, what specific problem would you be looking for during a physical exam? What kind of movement would be off? And the answer is a condition with a name that is quite a mouthful, dysdiadochokinesia. Yeah, I know. But don't worry about the word. The concept is actually really simple. It's just the inability to do rapid, alternating movements, like quickly flipping your hands back and forth over and over. And this is exactly what it looks like in the clinic. A doctor might ask the patient to quickly tap their foot, or pretend to turn a doorknob, or do that hand-flipping thing. Someone with a cerebellar lesion would be slow, clumsy, and really irregular with these movements, specifically on the same side as the lesion. Now, to really drive this home, let's compare. A cerebellar lesion gives you these coordination problems, like dysdiadochokinesia. It does not cause weakness or numbness or vision loss.
Those symptoms point to a problem in a totally different part of the brain, like the cerebellum or the brainstem. Our patient's problem is purely about motor control and timing.
So, let's boil this entire case down to the one essential rule you absolutely need to remember.
This is it. This is the key. A problem in one cerebellar hemisphere causes ipsilateral, that means same side, issues with limb coordination. Remember, the cerebellum is about smoothness and timing. It makes you clumsy, not weak.
And that brings us to our final satisfying answer. The headache pointing to pressure, the MRI pointed to the left cerebellum, and the cerebellum's quirky wiring rules pointed to a specific, same-sided coordination problem. The most likely finding is left-sided dysdiadochokinesia. Case closed.
But here's a final thought for you. We've seen how a very precise lesion causes a very precise problem. Which kind of makes you wonder, doesn't it? What happens when a substance like alcohol affects the entire cerebellum at once? That classic stumbling, the fumbling for your keys, that's your cerebellum being temporarily disrupted on a global scale. It's a powerful reminder of just how critical this small part of our brain really is.